So our next speaker is going to be a Tunisian experience in managed aquifer recharge by hill dam water release, case of some groundwater flow systems in north of Tunisia, and it's Anis Chekirbane.
Good afternoon, everyone.
Thank you.
My name is Anis Chekirbane, and I am a researcher in Water Resource and Technology Center in Tunisia. And today, I'm going to make a presentation about the Tunisian experience in managed aquifer recharge by hill dam water release, basing on some case studies of groundwater flow systems in north of Tunisia. So, as an introduction, I would like to show the location of Tunisia for people who don't know that Tunisia is located in North Africa, in the Mediterranean basin. It's characterized by mostly arid, semi-arid and arid climate. The average precipitation is 230 millimeter per year, and the total potential renewable water resource potential is estimated to be 4.8 billion cubic meter per year. Of them, 2.7 are surface water and 2.1 are groundwater. So this is the map of the distribution of aquifers in Tunisia. And in the legend, I'm sorry, it's in French, but it means the colors going until red. These aquifers are suffering from severe drawdown, going from 10 centimeter until more than 1 meter. So the groundwater resources in Tunisia are characterized by scarcity and overexploitation. There is severe drawdowns, quantitative and qualitative degradation, leading to degradation of groundwater. So the solution is managed aquifer recharge. And in the map, the green color shows the case studies where the managed aquifer recharge is applied. So the problem is that the managed aquifer recharge techniques are poorly monitored and almost not managed, not well managed. So there is a necessity to optimize managed aquifer recharge techniques in order to restore the aquifer equilibrium and ensure their sustainability. So I'm going to start with some insights about the managed aquifer recharge in Tunisia. So the MAR started in Tunisia in early 80s, and the artificial recharge volumes here, there is time series for artificial recharge volumes from 1992, where the managed aquifer recharge was incorporated in the management plans, water resources management plan of Tunisia. So this volume is fluctuating due to the water availability, which strictly correlating with rainfall. Concerning the techniques, so in Tunisia, almost 90%, let's say, of managed aquifer recharge is using hill dams or big dams in the central part of Tunisia. So most of these techniques are basing on the dams, the release from the dams. So the challenges, MAR challenges. So MAR operations are occasional. They are strictly depending from the available resource and the precipitation, of course. They are poorly monitored and practiced without scientific and technical optimization. So I'm going to present two case studies. The first one is a coastal aquifer. It's the Wadi El Khairat watershed located in North Tunisia. It's a kind of alluvial aquifer with Marley threshold drained by Wadi El Khairat. The climate is semi-arid also. Concerning its hydrogeology, so it's an underflow system composed by alluvial deposits of Pleoquaternary, and there is severe groundwater depletion because of overexploitation. So the second case study is the Saadin watershed, Wadi Saadin watershed. It's an inland aquifer located in north of Tunisia, in Zagwan prefecture. So it's a kind of alluvial aquifer also. The depth reached 40 to 70 meter. The climate is semi-arid also, and the aquifer is a kind of underflow system composed by alluvial deposits of Plio Quaternary. There is also a severe drawdown in some region, which we call in Tunisia Sea Subalam aquifer. So the objective is to assess the managed aquifer recharge, especially by dam water release efficiency, using simple tools and measurable parameters. Simple tools, measurable parameters, because we are working in close cooperation with the local water authorities, so we choose to work with simple tools and measurable parameters, basing on these two case studies. So the methodology is a pluridisciplinary study based on field investigation, data collection. Everything is stored in a GIS database. So reservoir characterization was carried out basing on geological outcrops, geological cross-sections, some geophysical surveys, results, especially vertical electrical soundings, electromagnetic soundings. The hydrodynamism of the aquifer also was examined basing on piezometric behavior, spatial and temporal. Also examined the exploitation of the aquifer. The quantification of the recharge was based on water balance equations, geochemical and isotopic tracers, and the end member mixing analysis. So all these techniques will allow us to construct a conceptual model and understand the efficiency of the MAR systems, MAR techniques. So let's start with the first case study, which is the Wadi Al Khayrat watershed. So there is here longitudinal cross-sections showing clearly that there is that the reservoir is subdivided in two units. The upstream one, which we call Garci unit. Then there is a threshold. Threshold is Marley substratum. We call that the hydraulic threshold. And then the second unit, which we call the Garci unit in the downstream area. We tried to assess first the managed aquifer recharge efficiency using the water table fluctuation in the upstream region. And as you can see here, this is the groundwater level. This is the time series of groundwater level measured in 5 piezometers compared with the released volume. And you can see here that since 2007, when the operation of managed aquifer recharge started, there is an effect, and almost all the piezometers are showing an increase. Then, from 2010 until late 2011, the operation was stopped because lack of resources, and you can see that the piezometric level is declining. Then, come to November 2011, there was a big flooding. So there is almost 145 or 150 millimeter precipitation, which caused inundation, flooding, which destroyed almost all the structure composed of the check dams. So from 2011, November 2011, the infrastructure was destroyed by the flooding. So this small increasing in 2011 is caused by the big release, the big volume of release, and also with the big amount of water coming from flooding. And then you can see that even after the operation of managed aquifer recharge come another time, there is no big effect because the infrastructure was destroyed. The second unit is the downstream unit. There is almost no effect because of the existence of this Marley threshold. Another technique which we use it is to assess the MAR effect are the geochemical and isotopic tracers. We took many samples in 2 seasons, and we analyzed them for major chemicals, and we find that there is hydrochemical similarity based on stiff diagram. There is some similarity, which is the proof of aquifer recharge from the released dam water. Also, we analyzed the stable isotopes, and the samples are basically divided into groups. The first one is rapidly infiltrated water in the recharge zone, and the second one, which is more important for us, it is located in Garci unit in the upstream region. It's enriched water, which means that there is mixing with the dam water. And then we want to go to the exact quantification of the dam effect. We performed an end-member mixing analysis, which says that every target water sample is a mixture of M components characterized by N tracers. I'm going in detail here. We are supposing, and after deep hydrogeologic characterization, that target samples near the aquifer are coming from the mixture of dam water, water from recharge zone 1, and water from recharge zone 2. Then we were able to calculate the fraction of contribution of the dam, which can reach 70% in the upstream region. The second case study, very quickly, is the Nadur Sawaf aquifer, mainly recharged by 3 hill dams, Ogla, Sahel, and Saadin. We are interested here in only Saadin watershed. We performed also a piezometric map. There is an interaction with the wadi and the aquifer here, based on the contour lines. And here I want to show that we want to perform the water table fluctuation, but the piezometers are very far from the study area. So the monitoring is not really so good. For that reason, we cannot notice any effect based on these 3 piezometers. We performed also, we calculated the water balance based on inflow, outflow, evaporation, and all fluxes. Fortunately, we have a time series of gauging stations of the every inflow and outflow at every portion. So we can estimate the infiltration or the recharge at every portion. And it shows here clearly that water can, the portion number 3 can infiltrate water only when we have big amount of water, big amount of available water. Also, we quantified by the same technique the end-member mixing analysis. Member mixing, we quantified the effect of the dam here, basing on only 2 end members and 1 tracer, and we find that the dam is contributing almost 50%, very close, in region very close to the hill dam. So as a conclusion, concerning Khairat watershed, the recharge impact is only observed in Garci unit because the existence of hydraulic threshold, which separate it from the infida. So because of the geology here, the recharge is reaching 77.5% in the region very close to the dam. Concerning the second inland watershed, the impact of managed aquifer recharge is not noticeable. using the water table fluctuation because of the high exploitation amount of the aquifer and sometimes conflict with irrigation use, and the recharge is almost 50%. So what we can learn here that the recharge efficiency is generally decreasing with the time because of the wadi bed clogging, more than 10 years of release. The recharge efficiency is variable along the wadi, and it depends from released water dam volume, which directly impact the recharge amount, the climatic conditions, especially evaporation, the lithology and morphology of the wadi bed. And we would like also to mention that monitoring is essential to assess the managed aquifer recharge efficiency. Piezometers close to the wadi and more gauging stations equipped with sensors are essential. And comprehensive hydrogeochemical studies coupled with numerical simulation can be an effective tool to optimize more the managed aquifer recharge in Tunisian case studies. Thanks for your attention.
All right, thank you. We have 3 minutes for questions. It's very bright. Okay, in the back, please. Microphone?
I speak now.
Thank you.
Beautiful presentation. I have 2 questions. One regarding riverbed clogging. In conventional rivers, where you have a riverbank filtration, they also clog. But the riverbed permeability is often recovered after a big flood. So my question is, in your November 2011 big flood, did you see a recovery of riverbed permeability?
Yes, yes, you are right. So just after the flooding, there was a lot of mud, and then little by little this mud is disappearing, and seems like the wadi is recovering and ensuring some recharge. I agree with you.
If I may allow another question.
Yes, please.
I also like your member mixing analysis to find the source of the water you have there. The problem I have when I do these things is that, okay, I know what the water is there, but I don't know how much is coming. So I wonder, what do you do to evaluate the actual amount of recharge from the end member mixing analysis?
So we are supposing, so concerning the end member mixing analysis, we should at first locate our target samples, which are close to the wadi or close to our system, and which the hydrogeological studies say that there is some connection in this location with the wadi. Then we identify our end members, and we assume that the water in this target well is composed from the 3 or the 4 or the 2 end members, recharge zone 1, recharge zone 2, and the dam. And then we can calculate easily the contribution using a system of 3 simultaneous equations, and we can calculate the fractions using 2 tracers. Here we use the oxygen 18 and the chloride. So it's possible to calculate these fractions very easily, just using a small matrix, small simultaneous system of simultaneous equations.
But I guess what his question is, what is the result? Like in the end, what's the end member that you calculated?
The end member is the contribution of the dam. The dam water.
In terms of percentage?
Percentage. Only percentage, not quantity.
But what is it? Because you didn't report that. Anyway, we can talk about that afterwards. Because thank you very much for this wonderful presentation on the basin scale, managed aquifer recharge. So I'm afraid we need to move on to our